Assalamualaikum warahmatullahi wabarakatuh. I am Nurul Syafiqah binti Abdul Aziz from AS2036A. I would like to present my review paper in the title Green Synthesis of Zinc Oxide Nanoparticle by using banana peel extract. As we all know, regarding from the previous researchers, nanoparticle synthesis have three syntheses which are physical, chemical and biological method. Usually, physical and chemical processes are used in the production of nanoparticles by using this commercial method, but physical techniques are incredibly costly, while chemical techniques are detrimental to the atmosphere and to the living organism. So for my review paper, my focus is on the biological method, as biological method have benefits as it is efficient and eco-friendly and consume less energy. However, for biological method, which is also called as biosynthesizing, that use microorganism, plants and fruits extract. Usually, all the plant's parts like leaves, stem, root, fruits and seeds have always used for zinc oxide nanoparticle synthesis because of their exclusive phytochemical that they produce. Biological method also used for synthesis because of highly stable and well-characterized nanoparticles. So the objective of this study are first to determine the effect of zinc acetate dihydrate as the precursor for the zinc oxide nanoparticle synthesis using banana peel extract on surface morphology and optical properties. Then, to characterize the surface morphology and optical properties of zinc oxide nanoparticles formed by zinc acetate dihydrate at different concentration using FTIR, SRD, SEM, UV visible spectroscopy. So we move on to the methodology. The chemical used was zinc oxide, zinc acetate dihydrate, sodium hydroxide, distilled water, deionized water, absolute ethanol, Cavendish banana peel, and Cavendish banana peel extract. The preparation of the extract, as mentioned in this slide, firstly, the Cavendish banana peel was cleaned with water deionized to avoid the dust and then moisture overnight at dry room temperature and cut into small pieces. After that, weigh the banana peel about 50 grams and add it into the beaker that contained 50 milliliter of deionized water and boil in 80 degrees Celsius for 30 minutes. Lastly, the peel extract will filter using filter paper. For the preparation of zinc oxide, as we can see in this slide, firstly, the 25 milliliter banana peel extract were added into the different concentration of zinc acetate dihydrate, which are 0.01 molar, 0.1 molar, and 1.0 molar. Then, the mixture had been stirred for 2 hours by using magnetic stirrer at room temperature, and after that, 0.02 molar of sodium hydroxide was added drop by drop to dropwise pH 12 and continue to stir for about 1 hour until it become yellowish. Last but not least, the pH of solution was checked and the precipitate has been collected using the suction filtration and repeatedly washed with deionized water and absolute ethanol and then dried overnight at 60 degrees Celsius in the oven. The characterization of zinc oxide have many techniques, but for my review paper, I use FTIR, SRD, SEM, and UV spectroscopy. The FTIR was used for characterizing the surface chemistry and also organic functional groups that attach to the surface of nanoparticles, and also the chemical residues were detected by using FTIR. In this slide, this is the example of FTIR spectra of the zinc oxide nanoparticles using jackfruit banana peel extract. From this slide, we can see that the distinctive absorbance band about 350 to 390 cm. Also, the concentration of the precursor used decreased and the sharpness of the peak of absorbance obtained also decreased. For this slide, it shows the FTIR spectra of zinc oxide nanoparticles using banana peel extract. So as we can see, the graph on the left side, the peak was in a 560 to 920 cm range due to the carbohydrate vibrations. The inorganic powder sample spectra suggest that they consist of zinc oxide. Next, for this slide, it shows the result of FTIR spectra of zinc oxide nanoparticles by citrus sinensis peel extract. We can see that in the SNP display spectrum close to the CNP, which is suggested that organic substances in the extract were thermally decomposed after calcination. The range of zinc oxide, as we can see in this graph, was in 400 to 600 centimeter range. In this slide show the FTIR spectra of zinc oxide nanoparticles by Punica granatum, fruit peels extract. In this graph, it measures the presence of various functional groups in pomegranate peel powder of zinc oxide nanoparticles before and after annealing process. The range observed peaks between 1000 to 1750 centimeter. Second characterization is X-ray diffraction spectroscopy. Usually, XRD is used for the phase identification and characterization of the crystal structure of the nanoparticles. This graph shows the XRD patterns of synthesis zinc oxide nanoparticles at different concentration of zinc acetate dehydrate by using Merck jackfruit banana peels. As we can see in this graph, the peak at diffraction numbers all above show the presence of zinc oxide nanoparticles. However, for this graph, it shows the PSRD patterns of zinc oxide nanoparticles by using banana peel powder. Well-established PSRD peaks indicate that the particles have been well crystallized. Next, we have graph of XRD pattern of zinc oxide nanoparticles by synthesis of Ailanthus altissima fruits aqueous extract. At the intensity 31.7 degree, it attributes to the purity crystalline from nanoparticles. In this slide, show the XRD pattern of zinc oxide nanoparticle synthesis by using Abemuscus esculentus mucilage. In this graph, the highly intense and sharp diffraction peaks demonstrate the high degree of crystallinity and purity of nanoparticles without any secondary phases. Third is scanning electron microscopy spectroscopy. As we all know, the use of SEM is for the morphological characterization at the nanometer to micrometer scale. In this slide, show the SEM image of zinc oxide nanoparticles using banana peel powder. In this image, we can see clearly the size, shape, morphology of zinc oxide nanoparticles. Next, the SEM image of zinc oxide at different concentration of zinc acetate shown in this slide. In image 4A and 4C, the lower concentration of zinc acetate that produce most rod light, while in 4B and 4D, with greater concentration provided zinc oxide materials in the sheet light form. For this slide, show the SEM image and EDX results of zinc oxide nanoparticles by using Celosia argenti. The average size used for this SEM image was 25 nanometers. Next, we have SEM image of zinc oxide nanoparticle synthesis from banana peel, which is Musa acuminata L. The SEM show that the visualization, shape and size of zinc oxide nanoparticles at range 350 nanometer at 1 micrometer resolution, and the zinc oxide nanoparticles seem spherical in shape. Lastly is UV-vis spectroscopy. UV-vis was used for characterizing various metal nanoparticles. The UV-vis spectra of zinc oxide nanoparticles using Musa acuminata L peel extract was shown in this slide. It showed the maximum absorption wavelength was seen at 351 nanometer. Next, the UV-vis spectra of zinc oxide nanoparticles using Musa acuminata peel extract, which is the type of banana family. In this figure, it shows the absorption spectra of zinc oxide nanoparticles at different pH. For this slide, it shows the UV-vis spectra of zinc oxide nanoparticles from A. paniculata. As we can see in this slide, the absorption peak ranging from 358 nanometer due to its surface plasmon resonance. The last result for UV-vis spectra is the UV-vis spectra of zinc oxide nanoparticles by Eucalyptus globulus leaf extract. The extract dominates only one peak at 257 nanometer, which referring the presence of benzene in OH group. As the conclusion, countless studies had been proved that the green synthesis to acquire zinc oxide nanoparticles by using various biological extracts including the banana peel extract is attainable. By using zinc acetate dehydrate as the precursor for the zinc oxide synthesis, it proved that concentration of both zinc source and biological extracts plays a crucial role to synthesize zinc oxide nanoparticles. Result on surface morphology and optical properties of zinc oxide nanoparticles formed by zinc acetate dehydrate at different concentration using FTIR, SRD, SEM, and UVV spectroscopy supported that statement. So that's all from me. Thank you.